Hello, today we will look at the superposition theorem. The superposition theorem is helpful with circuit containing multiple sources. A circuit can have multiple current sources or voltage sources. There can also be a combination of both the current and the voltage source, as shown in this figure. What is the theorem? The theorem itself states that the current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced independently by each source. So what do? We select a source and replace all the other sources. The current source is replaced by an open circuit. The voltage source is replaced by a short circuit. We then solve the circuit for each selected source and add the answers algebraically. Let's look at an example. We have been given a circuit with a current source and a voltage source. We want to solve for the current in the 6 ohm resistor due to both sources. We solve by making two equivalent circuits. We replace the current source by an open circuit and replace the voltage source by a short circuit. We first replace the current source by an open circuit. Now you can see that the circuit is a simple series circuit. We let the current through the 6 ohm resistor to be I2 prime. The I2 prime can now be calculated using Ohm's law, and it turns out that the I2 prime is 2 amperes. Notice the polarity. We take the current going downwards through 6 ohm resistor as positive. We now remove the voltage source and replace it by short circuit. We let the current in the 6 ohm resistor to be I2 prime prime. The current I2 prime prime is calculated by current divider rule. It turns out that I2 prime prime is 6 amperes. Notice the polarity. The current is still going downwards through 6 ohm resistor, so it is positive. We now add up the two currents going through the resistor R2. The I2 is equal to I2 prime plus I2 prime prime. And it turns out that I2 is equal to 8 amperes. And since both I2 prime and I2 prime prime were flowing downwards, I2 is also flowing downwards and 8 amperes. Thank you for watching this video.